Hello everyone, today I will be talking about a Matlab code which is animates a 3D rectangular through three rotational stages. First of all, as you see, my first code, which is like data sequence, which is rotation Z 45 degrees, as you can see here. Then I have here rotation X, which is 100 degrees, same as rotation Y. I have it 70 degrees. Then I have rotation X again, which is 60 degrees. And also I have rotation Z minus 100 degrees. And my last, which is rotation also U, but we can name it as a X because it's the same thing through the rota. So let's run this code and we will see what we will have as a final position. As you can see here, that's my final code. Yeah, so let's again run this code and we will see what's going to be the final position. And that's the final position. So let us see my second sequence, which is, now you will see that Y, I started it in different way, which is the new sequence as I wrote here, YX, Z, YX, completely different order. So first rotation we have here Y, which is 120 degrees. Here I have X, which is 80 degrees. And here I have Z minus 40 degrees. And here I also have 90 degrees for Y-axis. And also at the end, we have 150 degrees for X-axis. Let's run the code and see the same final position. And that's the final position, exactly the same thing as the code happened, the original one. So now I will be talking on my second part, which is what I had as a home task, which is implementing a function for to make shorter code without repeating to be repetitive. So here of course, I will close all, which is closes any existing figures in those. Then we have a view 130 over 30, which is sets the 3D view angle for a plot. By V, here I meant, which is the 8 times 3 matrix. And of course, each column represents vertex of the cube. Example, as you see here, for example, let's say semicolon, let's say 1. It's exactly like equal 0, 0, 0, the 3 zeros, which is means vertex A UVW. Exactly what I meant in it. Of course, here, as you can see, the edges as pair of vertex indices. Here I have the front face. Here I have the back face. Here I have connecting edges. About defining edges of the cube, like each row in E contains the indices of two vertices that form an edge. Example 1, 2, line from vertex 1 to vertex 2. That's what I meant in it, which is that this allows drawing all edges in a loop instead of writing like 12 line, like again, and to make it repetitive. Now I will be defining rotation sequence. As you see here, that's the rotation that I wrote. Here what I meant, for example, rotation axis, which is XYZ. Like rotations is a cell array, each row specifies rotation axis, XYZ. Number 2, I have rotation angle in degrees. which is R underscore total equal I3, which is initializes the cumulative rotation matrix. All rotations are stored in a single table, so we don't need to repeat the code for each axis or angle. Now I will be talking about the loop through rotations, which is as you see here, that one. R equal 1 size rotations comma 1, axis equal rotations R comma 1, angle rotations R comma 2, which is size rotations comma 1, that's the number of rotations. 6 in my case, because I have 6 different sequences. For each rotation, extract axis and angle. And now I will be talking about that rotate gradually. As you see in this part, inner loop gradually increases rotation from 0 to angle, which is the angle is the integer steps, of course. And like we have rota x, rota y, rota z are my rotations function around x, y, z axis. R underscore total keeps the previous rotations applied. R equal rot times R underscore total, new cumulative rotation applied to the cube. And here, now I will be talking about apply the rotations to vertices. As we see this, which is matrix multiplication rotates all vertices at once. Like V underscore rot is a 3 times 8 matrix of rotated vertices. And no need to compute, of course, AX, YZ, EX, YZ, CX, YZ, etc. And that's what I meant in that. And here, as we have, you see, which is CLA, fixed system mobile. CLA, which is clears the current axis for redrawing. Fixed system, which is presumably draws your fixed coordinates axis, your function. A mobile R presumably draws something that moves with the rotations, your function. Okay, so now let's talk about draw all edges in a loop. As we can see here. So loops through all edges in E. Edges is E. We used line connect the two vertices of each edge. Like this replaces dozen of repeated lines calls in my code. And here at the end, we will have, as you can see, update total rotation, which is forces Matlab to update the figure. And of course, it animates the rotations in a real time. Let's try to run the code and let's see the code. And as you see, it's exactly the same final position. Thank you very much for your attention and have a beautiful day.